So today's learning intention is graphing with logarithmic axes. Essential skills are going to be working with powers and indices, graphing straight lines, and applying the rules of logs. So some background. So very often scientists will obtain exponential graphs from experimental data. We've just seen before in the last video all about half-lives or growth of bacteria, any kind of population growth with exponential growth function, decays, anything dying off, especially with your radioactivity. They are awkward to graph and analyse. So one trick scientists use is to convert them into a straight line graph. Okay, then we can work out gradients, intercepts, life becomes easier. So the picture here shows you an exponential function, y equals a times b to the power x. So y equals a times b to the power x. So let's try a trick. Why don't we try and take the logs of both sides? I'm using the natural log here. Okay, now watch the brackets. I've got log y to the base e equals log of ab to the power x to the base e. Apply the rules of logs. Now remember, the first rule of logs was when you've got two terms you're multiplying together, you can split them up. So I've got log y equals log a plus log b to the power x. Simplify that further. Okay, so what I've done is I've brought that exponent x down, become a multiplier at the front. So I've got log y equals x times log b plus log a. There's a reason I've moved that to the front, because if you think about it, that looks really similar to y equals mx plus c. Okay, if I was to graph it with log axis, then that should be a straight line cutting at log a. Okay, so rearranging again, I've got log y equals, that's log b times x plus log a. So the gradient should be log b. It cuts the the y-axis at log a. I'm going to graph it. So I'm now going to graph log y versus x. And what we get is a straight line. So here they've put on the y-axis a capital Y, and I've written down that's the same as saying log small y, your y value, take the log of them and graph that versus whatever x was. And there we get a lovely straight line. So the curve is now a straight line. We can work out the gradients log b, and it cuts at log a. This can be very useful. This comes up time and time in questions. So we've got a straight line, gradient equals log b, y-intercept equals log a. We can use those facts to then work out what a and b are if they're unknowns in our problem solving. Example 1. The graph illustrates the law y equals ab to the power x. So the question says, from the graph find the values of a and b. So we're problem solving now. So you're told it should look like y equals ab to the power x. Now that's a times b to the power x. Okay, you can take logs of both sides, but natural log to the base 10. So we look at the question. The diagram shows us that on the y-axis it's log y to the base 10. So you'll take log to the base 10 on both sides. You have to rearrange step by step and show all you're working in the exam. So using your rules of log, simplify it. Log y equals log a plus log b to the power x. One step further, log y equals x times log b plus log a. Make it look like a straight line, y equals mx plus c. So log y equals log b times x plus log a. Now we can work out what a and b is. We can work out what a is from the y-intercept. So the y-intercept is 1, so log a to the base 10 equals 1. That means a is going to equal 10 to the power 1, which is just 10. So that's us found a. To find b, we're going to use the gradient. So the gradient equals log b to the base 10. So what is the gradient? You get 2 points on the line, so work out the gradient. So the gradient is going to be change in y over change in x, which is 6 over 3, which is 2. So we've got log b equals 2. So what's b? B is going to be 10 squared, which equals 100. And to finish off, you're going to write out your equation. Y equals 10 times 100 to the power x. Okay, brackets in there. Now we're not multiplying 10 times 100 is 1,000 because it's the hundreds to the power and then the multipliers at the front, so be careful. Another example. So example 2, the graph below illustrates the law y equals kx to the power n. That's k times x to the power n. It says find the values of k and n, and we've got a graph here with lots of information on it. I know the y-intercept. I've got another point on the line so I can work out a gradient. And I'm looking at the x and y axis. So they've taken the log of both axes there, and it's log to the base 2. So again, use your graph there. Okay, so start off at the beginning, y equals k times x to the power n. Take logs of both sides, and I'm taking log to the base 2 because that's what's in the question in the diagram. Using rows of logs, okay, separate k times x to the power n, and then bring n down to become a multiplier. And I've brought that to the front, that term to the front, because I'm trying to compare that with a straight line y equals mx plus c. That then tells me that the gradient m is the same as n because x is log x to the base 2 and the y-intercept is given by log k to the base 2. So using that points, to calculate n I'm going to calculate the gradient. So n equals the gradient, which is 3 over 6, which equals a half. So it's changing vertical over changing horizontal. To find k, I'm going to use the y-intercept. So the y-intercept equals log k to the base 2. So from the graph that equals 4. So solving that logarithm, k equals 2 to the power 4, which equals 16. And to finish off the question, I'm going to write out the function. So the graph below illustrates the law y equals 16 times x to the power a half. Example 3. As shown in the diagram, a set of experimental results gives a straight line graph when log y to the base 10 is plotted against log x to the base 10. And this straight line has a gradient of 2. That's the information you've been given. It's a 6-mark past paper question and it's asking to express y in terms of x. And you have the picture there to help you. So from the picture, you've got log of both axes, both x and y axis, and it's also got the y-intercept showing it 0, 1. Okay, so start from basics. Write the equation of a straight line. So that's y equals mx plus c. But in this case, the y-axis is log y to the base 10. Gradient, you were told that in the question, the gradient's 2. What's on the x-axis? It's log x to the base 10. And where's the y-intercept? It's at plus 1. So you've written that down. Apply your rules of logs in reverse. Sorry, I've rewritten then, so 1, I've put that into log 10 to the base 10 is just 1. Beg your pardon. Now your rules of logs. Okay, bring 2 up to become an exponent. So I've got log y equals log x squared plus log 10. Got 2 logs, you can merge them together. That gives me 10x squared. So log y equals log 10x squared to the base 10. Cancel logs on both sides. That gives me y equals 10x squared. Right, try these on your own. Okay, got 2 examples. Second one's a past paper for 4 marks. Take your time, pause the video, use your notes, and give a really good try at both examples. When you're ready, come back and I'll go over the answers with you.
Right, so example 1, here we've got the graph illustrating the law y equals ab to the power of x. So we can see from our graph that our y-axis is log to the base 2. So we'll take log to the base 2 of either side, and using our rules of logs, we can then rearrange and get log y to the base 2 is equal to x log b to the base 2 plus log a to the base 2. And we can see that this looks a little bit like y equals mx plus c. And if we just switch around and rearrange our log to the base 2b of x, we can then do our comparison. So in order to find the value of a, we know that log a to the base 2 is equal to the y-intercept, which is equal to 6. So 2 to the power of 6 is equal to a, so a must be 64. And then to find b, we need to look at the gradient, because our gradient is equal to log b to the base 2. So the 2 points on our graph are 0, 6 and 2, 0. And calculating our gradient would be 0 minus 6 over 2 minus 0, negative 6 over 2, which is negative 3. So if our gradient is negative 3, that means that log b to the base 2 is equal to negative 3. Therefore, 2 to the power of minus 3 is b. So b is 1 over 2 cubed, or 1 over 8.
Example 2. The graph illustrates the law of y equals kx to the power n. If the straight line passes through, you've got 2 points there. When you get 2 points, you can work out a gradient. To work out what k and n are, 4-mark past paper. Again, look at the graph. The y-axis and x-axis is both log to the base 5. So start off with the law you were given. Take log to the base 5 of both sides. Use your rule of logs, get it to look like a straight line. You're comparing gradient and y-intercepts. To find n, calculate the gradient. You have to work out what gradient is, so n equals minus 2. To find k, we're going to look at the y-intercept equals log k to the base 5. That's going to equal 1, so k equals 5 to the power 5, which is just 5. Sorry, 5 to the power 1, which is just 5. That's you solved it for 4 marks. So self-assess your progress, how are you getting on? Remember to ask your teacher for help if you need it. If you want extra work, then try page 299, questions 4 to 7. So what have we learned today? You've learned how to graph with a logarithmic axis. So when you graph an exponential function with log axis, you create a straight line. You've got two forms, y equals a times b to the power x, or you've got y equals ax to the power b. So two different forms. But in both cases, take the logs of both sides of the equation, apply your rules of logs, and rearrange into a straight line format, y equals mx plus c, and then using your knowledge of gradient and y-intercept to solve whatever problem you've got.